All right, let's talk about what a rational number is. It is any number where m and n are integers and n is not a zero. This is what it means by m and n. A rational number is a ratio. A ratio is a fraction. All numbers can be written as fractions if you want to. You just have a 1 underneath. But it is a fraction, and n cannot be 0, because if you divide by 0, it does not exist. It's undefined. So it's any fraction. It's a rational number, a ratio, but the decimal form, these are decimal forms, are either terminating or repeating decimals. This is called a repeating decimal. It goes 0.1313 forever. That is called a repeating decimal. And a terminating decimal is like 0.75, where there's no more numbers after that. So these are both decimal forms of a rational number, or of a ratio. An irrational number, or not a ratio, is a number that is not rational. The decimal form neither terminates nor repeats. So what happens is the decimals just keep going on and never have a pattern to them. So we are going to circle all of the following that are irrational, meaning the decimal format of them does not terminate or repeat. So the square root of 10. Well, we'd have to use a calculator to check that, but basically, even if you don't have a calculator, all square roots that don't make whole numbers, like the square root of 9 or the square root of 16, are basically irrational. So it's kind of quickly we'll just say that one's not, even without a calculator. Next one, the square root of 36 is a square root that makes 6, so that is not irrational. That's 6, that equals 6. 1/3 is a ratio, but almost all ratios are rational. They're a ratio. And if you took the decimal of this, it would have a repeating 0.333333 forever. So this is rational. It's a ratio. Here's a ratio, but it is a ratio of the square root of 25 is 5, the square root of 4 is 2. So this is really equal to 5 over 2, which 5 over 2 is 2.5. So that is a rational number. Next we have pi. Pi is the most popular irrational number because it goes on forever. It comes from the circumference divided by a diameter of any circle, and it just goes on forever. People love trying to memorize the many decimals as they can of it, but this is another irrational number. All right, this right here is a repeating decimal. We don't even have, this is the decimal form, and if it's repeating 125, 125, 125, that would mean it's rational. It comes from some fraction that would create that one. So here we go. We got a ratio again. I have a 3 over the 4th root of 81. Well, first you might say, it's radical. We can't do it. But again, the 4th root of 81, you got to be careful. This is really 3 over 3. The 4th root of 81 is that, which is really 1, which is completely rational. All right, next. The square root of 6 over 6. So another ratio. Let's see. The square root of 6, that is an irrational number. Over rational would make an irrational number, because if you have a whole bunch of decimals divided by 6, you're just going to have a whole bunch of decimals that don't repeat still. So this is an irrational number. All right, here we go here. 3/4 minus 2. Well, 3/4 is 0.75 minus 2. Oh, that's just a decimal that terminates. So that is rational. How about here? 3 minus the square root of 49. Now, square root of 49, you might think, oh, it's irrational. But no. You got to remember that the square root of 49 is really saying 3 minus 7, because the square root of 49 is 7, which that's just equal to -4, which is a number. Perfectly fine. You could write -4 as -4 over 1 if you want a ratio, but it's a number. Next, okay, the square root of 9 minus the cube root of 8. Well, let's see what each one is. That would be 3 minus the cube root of 8 is 2, so that's just 1, so that would be equal to an irrational number when we simplify that. Okay, keep going. The square root of 20 times the square root of 5. Well, both of these are irrational. Okay, so if we multiply two irrationals, is that going to be irrational? Well, we have to look more carefully here. Here's where it gets tricky. Well, if you multiply those two, you get the square root of 100. And the square root of 100 is 10. Oh, so when we multiply two irrationals, it doesn't always equal an irrational. It can equal a rational. Oh boy, that gets a little tricky. Okay, so that right there was, this right here is a rational number. That's a tricky one. Let's try this one. Two irrational numbers when multiplied, does that equal and another irrational. Well, that equals the square root of 15, and the square root of 15 is not a nice square root that breaks down evenly. It would be decimals that go on forever with no pattern. So this would be another example of another irrational number. Okay, next, this one. Well, these two individually, let's check what they are individually. They might not even be individually irrational. The square root of 4 is just, the cube root of 4 is some irrational number. The cube root of 16 is another irrational number. But when you multiply them together, you get the cube root of 64, which equals, not 2, but equals 4. Because 4 times 4 times 4 equals 64. So this is not irrational. This one is rational. Again, I have two irrationals multiplying to get a rational. Okay, here we go. Got to keep checking these things. Okay, here. Oh, this one looks weird. I have an irrational and an irrational. Let's see if this one works out. Let me see. 3 times 2 is 6. And the square root of 10 times the square root of 6 is the square root of 60. All right. Now, the square root of 60 does not break down nicely. 6 does. But when you multiply a rational with an irrational in this situation, you are going to have an irrational number. So this is yet another irrational number. So what we're kind of noticing, hopefully, is if we look at all these ones that are irrational, all right, most of them have a square root in it, except for this unique one. So if there's a square root, that's where you might have an irrational. And you got to make sure the square roots don't work out nicely. That one worked out nicely. That one works out nicely. It could also be a fourth root or a cube root. Two irrationals don't always, when you multiply them, don't always make a rational. So you got to be careful about what you're dealing with and how you're doing things when you're dealing with rational, irrational numbers.